Hello, everyone, and welcome to course P19, it deals with electrode routing. And that is, how do we get electrode from the drum, from the spool, from whatever the source, and all the way to the contact tip, undisturbed and correct the way we need to have it. Let's talk about a couple of things to do with the electrode routing. First, we always have to make sure we have nice, smooth transitions. Now, this gets to be a little bit of a problem when you have a robot and it has to make some pretty sharp turns to make the wire go around the corners. When it comes time for designing a system, the straightest possible route should always be considered. When it doesn't, there should be some method of controlling your bends. We'll get into that a little bit more later on, because it actually has to deal with the next part, which is an electrode guidance system. If you use a proper guidance system, it really doesn't matter what you do with it. When you go to you can use modules and so forth. We'll discuss later to go to sharp turns, to get 90 degrees, to get more than 90 degrees. Not very often can we go ahead and make a 90-degree bend without having some type of long-term repercussion. The last thing we ever want to do is have conduit set up in such a way that there's a drag on it to the point where you start to notch or groove the inside of your conduit system. And you have to use the right equipment based on what it is. The guidance systems have to be specific. So if you're using flux cord or copper free, you always have to take that into consideration when it comes to your guidance system. What you're using for the type of conduit, what you're using for the modules, for example. There's a difference between using plastic for the rollers and using steel for the rollers. So these are all things that have to be considered. So let's talk about the system for a moment here. We have our typical wire source, which either comes as a result of a spool or a drum or a derailleur. And then there's usually some form of a line to take us up to a bulkhead. And then we have a fitting, especially if it's robotic, and then we'll have something possibly at a bulkhead that goes all the way to the back of the feeder. Now, within this system, we've got a bunch of different threats to this system. So, and that is, every time you see a bulkhead, you see, okay, there's a possibility of scraping the wire. That's why it's important to look for all those little things when you take this stuff apart. Look for little bundles of what would look like steel wool. And then the type of conduit you would use that would take you as far as the wire feeder. And we'll talk a little bit more in more detail about what goes on at the drive rolls here. We understand tension, but we also have to make sure our guides and everything are in place. And then, of course, the electrode has to take the trip through the whip and out the front of the consumables. So there's essentially two different types of different drive rolls. We've got V groove, we've got U groove. There is another one that's related to different types of wire for cord wire and sometimes for aluminum that we know as knurled drive rolls. There is nowhere left for knurled drive rolls in the systems anymore. Even if you're using flux cord, most companies, especially Miller, are the first to say you should be using a U-groove drive roll to spare your consumables, to spare your conduits and liners, to make sure that the sharp edges that were left from knurled drive rollers don't start to cut everything. And that's actually what ends up happening is when it goes through the drive rolls, you get this little bit of a cut. And this little cut starts to grind away at the inside of your consumables. Keeping your drive roll tension under control is important. Keeping your drive rollers clean. Drive rollers are really important, and you need to be very careful to make sure that they don't get chipped or they start to get rough on the surface, because this roughness will translate to the surface of your electrode. If your electrode surface is rough, I'll guarantee you there will not be a smooth transition of power to your electrode. So you have to be careful that you're not embossing. Most companies have some level of an inspection process. I like to bring it up because some companies don't. But you should have a method of making sure that the drag is recorded in its pristine condition from the first stage, and then to the second stage, and then from the third stage, to get us down to the back to the nozzle after it takes its trips. If anybody needs information on this, please give me a call. I have all kinds of documentation that a person could fill out to take the data they need to do all the troubleshooting. Remember this, when it's running well, that's one of the most important times that you can have, because now you get a chance to examine what particular information is available to you, so if you ever have to troubleshoot it, you can go back to it. So for example, if all of a sudden it took 4 pounds to pull all the way to my bulkhead, 4 pounds of tension, and I use some type of a tensile tester, and then I have problems and I test that and all of a sudden it's 15 pounds, it should be investigated. What's going on? Do I occasionally have a lump of wire that's spinning around inside this drum giving me a hard spot? And then of course it pulls past it and it goes away. But it could be in the winding, it could be a bunch of different ways. So if you ever want to set up a system or anything like that, you want some more guidance on that, please give me a call and we can take care of that for you. Here's some of the typical paperwork that I'd send to gather measurements. And again, the most important time is when everything's running good. So now we want to do something to record how everything's running good, so when it goes wrong, we have somewhere to go. So I'll help people with this document and help them with the support document to make sure that everything gets done. And you can just contact me and I'll look after it for you. Here's a typical Wire Wizard configuration. Now, Wire Wizard are my always going to be my recommendation, because they have international connections. Everybody can get them. They're well known for their durability, and if they're put in right, you never have to think about it again. And this particular one is for a solid wire, and the wire itself goes through a plastic rolled set of modules there. Those are 2 modules, 2 45s to make a 90. And as it goes up and through, there's literal drive rolls that keep it in shape. It comes out the other side, and there's actually a 45 on the other side that handles a little bit of the droop from the bulkhead, and that little bit of a droop in the conduit then goes to the back of the robot, and we use a heavier wire line conduit for that part. We don't want it to be light. We want it to be substantial and strong, because the robot's going to be whipping around. So this is your typical setup. This is a different type. This is from Feronius. Feronius actually have these long pieces of conduit, and they all have their own little roller systems in each one. They actually make a repair kit, but the problem with the repair kit is you don't know where the drag is coming from until you take it all apart. So even though you've got a repair kit to put it back because it's broken, you still don't know what part is bad unless it's just physically broken. These are kind of okay if you're running to the robot, because you can come off the top of the drum, do 90 degrees. It could go down to the ground and then turn towards the job and literally run the wire right to the robot underneath. So it's just another method of doing it. Thank you very much for your attention. Have a good day.